Welcome to the Predictive Maintenance demo. In this section, we're going to be highlighting the real-time capabilities of the IBM SPSS platform for predictive maintenance. The scenario for this demo is that we have a group of production line robots where we are capturing sensor data, inspection logs, and maintenance logs, using that data to train predictive models. These predictive models are able to determine the reliability of every robot at any point in time, given a set of operating conditions. The models are using the neural net and logistic regression algorithms, although there are a large number of algorithms available from the platform, and we use whatever algorithm is most appropriate for the data set. Since we have pre-trained these models, we've gone ahead and deployed them into the SPSS deployment platform, the Collaboration and Deployment Services platform. This platform makes it possible to access these models and to score new data, that is, new condition monitoring data for each robot, in real time. The scoring is done via a web service call from a platform such as Java or .NET. Typically, this can either be a BI application that is providing real-time dashboarding, or a console built a simple one for this example for you to be able to view. Let's go ahead and take a look at the actual application running in real time. Here we are in the predictive maintenance console. As you can see, we are monitoring a production line of robots. Each of these gauges represents the reliability of a single robot. Fortunately, most of our robots are experiencing no likelihood of failure. However, we do see a number of robots that appear to be in an alarm state where we need to address the issue that's affecting reliability. Let's drill down on robot 865. As you can see, there are three different failure modes identified here: the bushing, the servo, and the switch failure modes. And in this particular robot, we see that the switch is the component that is likely to fail. If you notice, we are streaming in the sensor log data in real time to this predictive model. Every 500 milliseconds, we are streaming that data to the model and generating a failure likelihood. As the condition monitoring values vary slightly, the probability varies slightly. It's taking interactions between all the different pieces of data into account. Let's take a look at another robot, robot 26. Again, we are seeing a likely failure, but this time in the servo motor. From our previous work, we noted that operating amperage was the key indicator of a servo motor failure. As we can see, this robot is operating at 48 amps, well outside the normal operating conditions. Let's drill into one of the robots that's not experiencing any reliability issues. And even though we are streaming in this condition monitoring data, none of the values is leading to an increased failure probability for the bushing, the servo, or the switch. What would happen if we actually increased the amperage to this robot? Would we see an increase in failure? So I'm going to go ahead and click the green button here and increase the amperage in real time. And as you see, the amperage ramps up as we sample this data every 500 milliseconds and feed it to the predictive models. With this increased amperage, you can see that we would drive a servo motor failure. So as we've seen in this demo, it's possible to determine the reliability of a large number of equipment assets in real time at a very short interval by monitoring condition monitoring data and feeding it to the predictive models to determine the reliability of each piece of equipment at any point, either in real time or in the future.